Welcome back, students. In today's class we would be learning how to solve this cubic equation. The coefficient of x cubed is root 3 and you have a constant term 4 here. I would not be employing the cubic formula. Instead, I would be using simple algebra to obtain the solution. So foremost, let us multiply by 3 throughout. So when I do that, I would be getting 3 times root 3 times x cubed negative 3 times x squared positive 12 equal to 0. Next, I would make the substitution v to be as root of 3 divided by 2 times x. Now this would mean v squared would be equal to 3 divided by 4 times x squared, and v cubed would be 3 times root 3 times x cubed divided by 8. So the original equation, which has now been in this form, I'm naming it as 2. So therefore equation 2 can now be rewritten as, in the place of 3 times root 3 x cubed, I'm going to be substituting this one, which in this case is going to be 8 times v cubed is equal to 3 times root 3 x cubed. So this would be the substitution. So 8 times v cubed. In the place of 3x squared, I would be substituting 4 times v squared is equal to 3 times x squared. So this would be negative 4 times v squared added with positive 12 equal to 0. Now clearly, if you were to add up the odd coefficients and compare it with the even coefficients, clearly you would see that they would be equal. So that would mean I can substitute v to be as negative 1, and that would be a solution. So since v is equal to negative 1 as a solution, what I'm going to do, I'm going to be using synthetic division. So this is going to be 8, negative 4, and I don't have a v term, so it's going to be 0 and then positive 12. So place negative 1 there, bring 8 down. 8 times negative 1 would give me negative 8. Add negative 8 with negative 4, that would be giving me negative 12. Multiplying negative 12 with negative 1 would give me positive 12. Add positive 12 to 0 would give me 12. 12 multiplied with negative 1 would give me negative 12. So clearly I get 0. So the quotient in this case is going to be 8 times v squared negative 12 v positive 12. So therefore 8 times v cubed negative 4 times v squared positive 12 is now rewritten as v positive 1 times 8 times v squared negative 12v positive 12. Now since it is equated to 0, this is going to be equated to 0. So clearly we can say that v positive 1 equal to 0 is a solution, and 8v squared negative 12v positive 12 is equal to 0 will also give us a solution. Now v positive 1 would be giving us one solution, so this is a real solution. But since the degree is 3, the other two solutions are going to be complex. Now we are expected to solve this. If I were to divide by 4, this is going to be 2 times v squared negative 3v positive 3 equal to 0. So by quadratic formula, I would now have v to be equal to 3 plus or minus root of negative 3 whole squared negative 4 times 2 times 3 divided by 2 times 2. So this is going to be 3 plus or minus square root of 9 negative 4 times 2 8, 8 times 3 is 24 divided by 4. I can rewrite this as 3 plus or minus root of, so this would give me 15 with the negative sign, so negative 15 divided by 4. So let me use this space on the right side. So clearly the roots would be 3 plus or minus. Now I have a root of negative 15 divided by 4, right? So that would mean I can rewrite this as 3 positive 15I squared divided by 4. In fact, I don't need to write this as V1. I'm just writing it as V. Okay, so plus or minus. So that is going to be, now I can write two roots. So one root would be 3 plus I times root 15 divided by 4. And the other one is 3 negative I times root 15 divided by 4. Now, the value of V, we have assumed the value of V to be as this. Okay. Now, we have three roots. One is real and two of the roots are complex. So what I'm going to do is I have to make the final substitution. Now, the roots that we obtained are as follows. That means they are V is equal to negative 1 is a root. Now since V is equal to root 3 over 2 times x, hence we can rewrite this as root of 3 over 2 times x is equal to negative 1. So root of 3 times x is equal to negative 2. So therefore x is equal to negative 2 over root 3. So this is one end. The next one is substitute the value of V. So root of 3 over 2 times x is equal to, this is another root, so 3 positive I times root 15 divided by 4. So this can be rewritten as root of 3 times x is equal to 2 times of 3 positive I times root 15 over 4. Now 2 divides here 2 times, so I now have root of 3 times x, 3 positive I times root 15 divided by 2. Of course, I can rewrite this as x equal to 3 plus I times root 15 divided by 2 times root 3. So the other one is going to be 3 negative I times root 15 divided by 2 times root 3. So the solution set is going to be negative 2 over root 3, 3 negative I times root 15 divided by 2 times root 3, and then 3 positive I times root 15 divided by 2 times root 3. So this ends the solution to this question.